So good evening everyone and welcome to today's lecture. This is lecture number 9 and we are going to do dielectrics in this lecture. Now first of all we have to understand what is a dielectric. Do you know what is a dielectric? Anyone? Dielectric. Dielectric are nothing but insulating materials. They are nothing but insulating materials. Dielectric are nothing but insulating materials. Don't get confused. Up till now, we were dealing with conductors. Now we are dealing with things which are not conductors. So they are insulating materials. As simple as that. Okay. So dielectrics are insulating materials. We'll only cover those parts which are required. So dielectric are insulating material. Now every dielectric has a value which is known as dielectric constant. What is this dielectric constant? Can anyone tell me what is this dielectric constant? What is a dielectric constant?
Yes, sir.
K, sir. Okay. Now, let us try to understand dielectric with one or two diagrams. Now, let us say that this is a capacitor and there is an electric field inside the capacitor. We know that there is an electric field inside the capacitor. This electric field is E naught. So this is the original field inside the capacitor. There is no medium inside the capacitor. The medium is only air or vacuum. Now what happens if I introduce a insulating medium which is known as a dielectric. Now if I introduce this insulating medium or the dielectric, as you can see, this is a dielectric here. This one is a dielectric. Now because of this dielectric, what happens? Because of this dielectric, what happens? The charges are introduced. There are charges which are introduced on the dielectric. The face which is facing this is the positive charge of the capacitor. The face which is facing the positive charge gets a negative charge. You can see this negative charge. Negative, 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 negative. And the face which is facing the negative charge of the capacitor, negative plate of the capacitor, it gets a positive charge. Positive, 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 positive. Do we understand this? When we put a dielectric slab in a capacitor or in any external field, there are charges which are introduced on the dielectric. Now, because of the charges which are introduced on the dielectric, the net field inside the dielectric becomes the original field E naught divided by K. The net field inside the dielectric becomes the original field divided by K. This K is known as the dielectric constant. So what you have to remember about a dielectric? what you have to remember about a dielectric. Have you drawn this diagram? Have you drawn this diagram? I'll give you 2 minutes.
No, sir.
I'll give you 2 minutes. Draw the diagram, then I'll give you one more diagram. So we understand this. In terms of capacitance, I will try to draw a diagram without the capacitance and try to make you understand what happens when there is a dielectric inside a external electric field. So what we have here, what we'll have here is what we have here is a dielectric, as you can see. Now what we are going to do, this dielectric is going to be placed is in an external field. So you can see this pink field is an external electric field, and this, I am taking this external field as uniform. So this external field exists like this. The value of, let us say, this external field is E naught. Do we understand this? Now because of this external field, what happens is on this side negative charge come on the dielectric, and on this side positive charge comes on the dielectric. Now because of this positive and negative charge, the dielectric starts to have its own electric field inside this, which is given by the yellow thing. Do we understand this? Because of this positive and negative charge coming on the dielectric starts to have its own electric field, which is going in the reverse direction. So what happens, my dear friends? These two electric fields overlap, and the net electric field in the dielectric goes in the green direction. This green field that I am drawing is the net electric field inside the dielectric. This E that I am drawing is the net electric field inside the dielectric, and that is what you must understand, that the net electric field inside the dielectric is equal to the original electric field E naught divided by a constant K. This constant K, my dear friends, is known as the dielectric constant of the body. Do we understand it now clearly? Do we understand this thing now clearly?
Yes, sir.
So I place the dielectric in an external field E naught. Because of this external field, charges are induced on the dielectric, which creates the yellow field. You cannot see the yellow field because it has been overlapped. Because of this yellow field, the net electric field inside the dielectric becomes E naught by K. This K came to be known as the dielectric constant of the medium. The value of K for a dielectric, also remember this and also write this. The value of K for a dielectric varies between 1 to infinity. The dielectric constant varies from 1 to infinity. Remember, one more point, for conductors, the value of K is infinite. For conductors, if you talk about conductors, for conductors, the value of K is very large. You can take it as infinity. These are the two things that you must remember. The value of dielectric constant K lies between 1 to infinity, and for conductors, the value is infinity. Do we understand this? Now you noted it down. This K is also sometimes known as relative permittivity. Relative permittivity. Relative permittivity. Epsilon R. I'll give you 2 minutes to note this down. Everybody understands what I have written here?
Yes, sir.
I'll give you 2 minutes to note it down. Okay. Having understood the dielectric constant, what are we going to do now is to understand what happens when this dielectric is put inside a capacitor, completely filling up the capacitor plates. So what happens when capacitor is placed inside, when the dielectric is placed inside a capacitor? So you can say dielectric, effect of dielectric, effect of dielectric on capacitance. What is the effect of dielectric on capacitance? Dielectric, remember, capacitance of a capacitor depends on the medium between the plates. Do we remember this? Yes or no? We understand this. We remember this. Yes or no? Capacitance of a capacitor depends on the medium between the plates. Yes or no? No or yes?
Yes, sir.
So when we put a dielectric slab inside the capacitor, what happens? Any idea what happens? For example, if I have a capacitor and I completely fill the space between the plates of the capacitor. Let us say this is positive plate or plate number 1 of the capacitor. This is the second plate of the capacitor, and what I have done, I have filled the capacitor completely with a dielectric slab, insulating medium completely. Now, if I do that, what happens on the capacitance? The new capacitance, let me call this C dash, becomes K times C. What is C? C is the original capacitance. So the new capacitance C dash becomes K times epsilon naught A by T. So when please first note, first remember, first understand what I am writing, then you note it down. When a dielectric slab is inserted, when a dielectric slab is inserted inside a capacitor to completely fill up the space, so there is no space left, then the capacitance becomes K times the original value. We have seen that before also, yes or no? Then the capacitance becomes K times the original value. We have solved question on this when the capacitor was completely filled up with oil, dielectric constant, and we have done questions on this. Yes or no?
Sir.
Yeah, so this is now we are going to understand the concept again with some more variations of the question. So, what is the effect of dielectric on capacitance? If you insert the dielectric, completely filling up the space, the capacitance becomes K times. I'll give you 2 minutes now to note it down. So what we are discussing is what happens when you fill the plates, the space between the plates of a capacitor completely with a dielectric, the capacitance becomes K times. Now, normally whenever you are going to get a question on this type, Now this process could be done in two different ways. Two different ways. Now we can, while you are inserting this plate, not a plate, I should call it inserting this slab, you can keep the battery connected or you can keep the battery disconnected. So this process can be done in two ways, whether the battery is connected or whether the battery is disconnected. So that is what now we are going to see. Battery connected, what happens, and battery disconnected, what happens. This is a very important aspect because whenever I have seen a question based on this, it is from this part, whether the battery is connected or whether the battery is not connected. So please, I request you, please understand this concept very clearly, that what is the difference between the two cases. One is battery connected and the other one is battery disconnected. So what happens in the case? What happens in the different case, and what I will do is I will show you the entire table, and I'll give you the important points. Please don't note it down unless I explain them. Once I explain them, then you are at liberty. I'll give you enough time to note it down. Okay, here we go. Listen to me very carefully. This is the most important aspect because 99% of questions are going to come from this part. Please give me 5 minutes. Now, here in case number one, I will call it the pink case. In this pink case, the dielectric slab is inserted, but the battery, once we have charged the capacitor, we have removed the battery, and then we have inserted the dielectric slab. Battery is removed after charging. In this green case, case number 2, the capacitor is charged and we have the battery connected, and then we are inserting the dielectric slab. Do we understand this? Both of you? Both of the cases, do we understand? Yes or no?
Yes, sir.
In both the cases, whether you disconnect the battery or whether you do not disconnect the battery, the capacitance in both the cases will become K times. Will become K times. What is the difference in the two cases? In case number 1, battery is removed. Now, if battery is removed, the capacitor, whatever charge the capacitor has, remember, then the capacitor becomes an isolated body. If a body is isolated, the charge of the body will remain constant. And therefore, in this case, pink case, the charge of the capacitor will remain constant. But in this green case, the charge will actually become K times the original charge. Extra charge will flow and get deposited on the capacitor. We understand this point?
Yes, sir.
Charge remains same, but something changes. Here the potential difference becomes 1 by K times. Remember, the only equation we know is Q is equal to CV. In first case, Q is becoming K times and therefore C is becoming, what I'm saying, Q is remaining constant. Potential becomes 1 by K times and capacitance becomes K times. In case number 2, again, the same equation is valid. Q is equal to CV. Here, the charge becomes K times, but the potential remains same. Do we understand? Since the battery is connected, potential difference remains same. We understand the 3 points?
Yes, sir.
Since the Potential difference becomes 1 by k times, electric field becomes 1 by k times. Here battery is connected, potential remains same, therefore the electric field remains same. And the last and the most important point, here energy becomes 1 by k times, because I can use the formula q square by 2c. Here I will try to understand the formula q square by 2c, because q is same for both the capacitor before the dielectric and after the dielectric. I can write the energy is inversely proportional to capacitance. But you see here also, here we can use the formula half cv square, half cv square. Here v remains same, so energy will become k times this is written wrong, so you just take this out. So here the energy u dash becomes k times of u, because potential is remaining same, it is directly proportional to c. C has become k times, and therefore the energy has become k times. Do we understand this?
Yes, sir.
Do we understand what I have discussed here? Have you everyone understood this?
Yes, sir.
Now in some cases it will not be given what is same, whether the battery is connected or battery is disconnected. So if nothing is said, then what will you assume? If nothing is said, then you will assume that the battery is disconnected, and that is the node that you will write. If nothing is said, it is just said we have a capacitor, we put the dielectric inside the capacitor, that means the battery is disconnected. Do we understand this? Everyone has seen and understood these diagrams that are there, very important diagrams, very, very important ones. Everyone has understood this?
Yes, sir.
Now I'll give you 5 minutes. Draw the diagram, write things down. If you have any doubt, please let me know. 5 minutes. This is the question. A capacitor when filled with a dielectric K is equal to 3 as charge Q naught, voltage V naught, electric field E naught. It is replaced by a dielectric constant 9. What are the new values of charge, voltage and field? Which case is this? We have done two cases, yes? Which case is this, beta? Which case is this, beta? I'll give you 2 minutes to give me the answer. Which case is this? Yes, it is the case where battery is not there, battery is removed. So now give me the answer. If you know which case is this, then the answer you should know.
Sir,
Yes,
is it option D?
it is option D. It has to be option D. So this is the case where battery is removed. Battery is removed because nothing has been mentioned. Nothing has been mentioned. That means the battery is removed. So if the battery is removed, the charge will remain constant. Yes or no? The charge will remain constant. Both the value of V naught and E naught will become 1 by K times. Basically, we can think it of this. K is 3, now K has become 9. So basically, it has become 3 times, right? So the value of new K is, let us say, 3 times. Or, do you understand what I'm saying? Or you can do it this way. If the original charge will remain same. So original charge on this, original charge, if I call about the original charge would be how much? Q
Q
naught.
naught.
Original charge will be how much? Q naught. What about the original voltage?
V naught by 3.
Original voltage. Original voltage would be 3V0 because it becomes 1 by 3, therefore it becomes V0. Original electric field will be 3E0. Do we understand this? These are the original values without the dielectric. Now, when you insert this green dielectric, the green charge becomes, it will remain same because that does not change. The green voltage becomes 1 by k times. So 3V0 by 3, it becomes V0. The green electric field becomes E0. Do we understand what I am doing here, bacha? Now I move to the blue wala dielectric. The blue wala dielectric is 9 wala dielectric. So what is the blue charge? Charge will remain same, Q0. What is the blue voltage? Original voltage was 3V0, 3V0 by 9. So the new voltage becomes, with the blue dielectric, it becomes V0 by 3. The new electric field becomes E0. The original field was 3E0, 3E0 by 9, E0 by 3. The only option which is matching this is option number D. Do we understand this? Do we understand this?
Yes, sir.
Pakka, sir?
Can you repeat?
What have you not understood, beta?
Sir, original charge, how did you get?
Original charge will remain same. That is how I got it. Charge does not change. Battery is removed. You understand this? We understand this?
Yes, sir.
Okay, before going, we will do one more question.
Sir, 1 minute.
Have you done it? Everyone? Okay. Shall we move on to the next question?
Sir, 1 minute.
Okay, then we will do it in the next class because the time of the class is getting over. So I thought that I will be able to do it. Do we understand how this question was
Yes,
done?
sir.
The green one is the values that are given to us. From that green one, I have found out the original values. From that original values, I have found out the new blue values. We understand this, everyone? Girls and boys together, do we understand this?
Yes, sir.
Yes, sir.
Okay, then we will continue with problems on this type. In the next class, we will be dealing with problems. Don't worry, I'll give you enough problems so that this concept is clear, because I'm hoping that you are going to get a question on this one. So we will continue with the questions in the next class. Take care and may God bless all of you. Bye bye, beta.